All right, so thank you all for coming to the workshop. You're here for Tillicum containers. This is part of a series of workshops that we've done starting in fall with Tillicum onboarding and then Tillicum Slurm, which is our job scheduler. Today we'll touch on a lot of skills across Tillicum, but if you do have any gaps in what you're doing, you can go back to our previous workshops and check those out. I'm Kristen Finch. I'm the Director of Research Computing Solutions, and my main job is to make sure that you all know about and can use our research computing service. And one of my favorite things to do is to put on these trainings to bring you all up to speed and make sure that we've lowered any barriers that you have to being able to adopt our services for your research projects. I just want to talk about how this is going to go. I've got a little bit of an introduction just to remind you what Tillicum is if you're very new to this, a little bit about software on Tillicum. We're going to talk about what a container is and why you want to use one, which is probably why you're here. And then we'll have our tutorial. We'll lay out what that looks like. So just a little bit about Tillicum. It is our newest GPU cluster that is on premises at University of Washington, managed by UWIT, specifically research computing and the HIAC team, HIAC and Tillicum team. And it's actually in the data center that is in the UW Tower. So like the biggest building over there on the first floor, there's a data center, so not too far away. It is filling a need that, of course, we all realize that there is a need for more advanced computing solutions for artificial intelligence jobs, training artificial intelligence, fine-tuning these models, finding solutions that might help us in our everyday life. Also, GPU accelerated scientific simulation. So as time goes on, all of the software is finding that it can really be accelerated if the developers are able to change the code so that it can utilize the GPUs. And so we're trying to bring that opportunity here as well with Tillicum, as an addition to our HIAC clone platform. We're also enabling interactive workloads. So we have an open on-demand platform, which is not going to be the star of today, but it has been discussed in the onboarding workshop earlier this term. It allows you to use, right now, Jupyter notebooks interactively with the supercomputer behind it. And we'll be adding additional applications to that platform as we go on, again, just making it easier to use. And finally, we have some data storage on Tillicum. Of course, you need a place to put all of the beautiful data that you're using. But we also host common data sets, and this is a list of the data sets here. I'll talk more about this later. We're actually going to use one of these common data sets today in the task. And we take nominations of common data sets, so you can tell us, hey, my lab and this lab are at least using this, and here's all the information about it. Can we host it on Tillicum? And more than likely, we will say yes. All right, just a little bit. So Tillicum is a usage-based model. You don't have to worry about this today, because today everything is free for you. But it is a pay-as-you-go model, and it's based on the GPU hour. And this is strictly controlled through Slurm. So anything that you're doing on Tillicum, like just moving around the cluster, working on your code, text editing, that doesn't cost you anything. But as soon as you start a job, that job is counted as a pay-as-you-go chargeable job, and it goes on the amount of time that you actually spend running that job multiplied by the number of GPUs that you required for that you requested. So even if that GPU is not being used, it will be charged, you'll be charged for it. So it's your responsibility to make sure that your code is using all the GPUs that you have access to, or else that's just wasted money. But that clock stops as soon as your job terminates. So even if you think, oh, I don't know how long my job is going to go, I'm just going to request 12 hours, but then it ends after 6 hours, which is not super efficient. You should do better than that. But you will not be charged for the extra 6 hours that your job was not running, but you thought that it might. And we'll get more into that a little bit. The price is 90 cents per GPU hour for your production jobs, and we have monthly billing. Usually we're going through to your PIs, if you're students, to talk about this. They're the ones that have to worry about the money stuff. There will be student programs in the future where you can apply for credits to use Tillicum after you've demonstrated that you need that scaling and that big beefy GPU that we're going to talk about. So no charge, like I said, we have some persistent storage for your lab groups. And we also have temporary storage known as the scrubbed directory, and that we're keeping those data for you for 2 months, so 60 days. And they need to be modified in some way for those to stick around. So if you're doing active computing, that's where you can store those files, but if you need them for long-term use, you use your dedicated storage. Data import and export is free, of course, and we have Globus set up as an endpoint on Tillicum. I'll show a little demonstration with that. But that, I think, is the best way to get your data from your local computer or somewhere else, from Hiat Clone onto Tillicum, making your transition to using Tillicum from Clone or some other platform easy as pie. Data parsing, again, you don't have to pay for this as long as it's happening on the login node, but if you're using an interactive node with Slurm to test out your code, that will be charged. And finally, user support, me and Kai Chen and Rob and everyone on our team is never charged to you, and you can always ask us questions. Added benefit of our services. Finally, there's no long-term, just like on Hiat Clone, it's not permitted for long-term storage, so you want to be moving stuff off and keeping only that storage that we've allocated to you for your active computing projects. All right, a little bit more about Data Commons. The requirements that we have for you to add something to a Data Commons set, or a data set to our Data Commons, is that your data must be open source and free to use. So of course, anything protected that's just been given to your lab, you have to deal with that. Because we want this to be for everyone to use. You need a minimum of 3 research groups and 3 specific users showing that they also will be using that data set. And then we also request that you help us to write the documentation page that talks about those data. And so this PDF will be sent to you in the follow-up email. And so you'll be able to find this information very easily, but it is on our documentation website. So more about Tillicum and software, the reason why we're all here. So as you know, Tillicum is a shared research environment. It has a baseline computing environment, which I will talk about more later. This means that we cannot give root access or sudo access to users because we need to protect and make sure that it's still accessible to everyone. And so we keep that access, and we're here to help you do anything that you need to do. And this training is about telling you one method, just one method, that will make it easier for you to do those things more independently.
Can I ask a question?
Sure.
So we're headed towards containers.
Yes.
And containers are like working environments. And I'm just like curious, is it correct to think of the container work that I'm going to build as a sub-environment where I am super user?
Yes.
Okay.
So you're not technically super user. And that's the beauty of Apptainer. With Docker, you are super user, which you're going to have a Docker container. It's like I planted you in the audience to ask this question. Rob has a Docker container training coming up in December 2nd that is already been posted. So if you're interested in that, that's a more like local development. You are the root user, but you can push those containers to Docker Hub and pull them into Tillicum, which I'm going to show you how to do. But our Apptainer runtime software actually means that you don't have to be a root user to be able to manage this environment as if you were the root user, but it's isolated away from the host kernel. And so we can give you that access without risking anything else. So it's kind of like sudo.
PSEUDOSUDO. Yeah.
There you go. Yeah. All right. So, but on Tillicum, of course, it's your work that you're doing on Tillicum. So of course, it's your ultimate responsibility to ensure that everything that you need is to be installed. But like I said, it's our responsibility, obligation, and our whole job to make sure that you can do that. All right, so a little bit just about Tillicum's baseline environment. It's a Rocky Linux plus Slurm is the job scheduler. We do have open on demand with Jupyter Notebooks, like I mentioned right now, but we'll be adding more to that. Our containerized environments have an Apptainer runtime, and that's because it's very suitable to shared HPC environments. We also have LMOD modules. These are maintained and contributed modules. Hopefully in the winter, we'll be having a training about how to customize a module yourself. But we do have documentation about modules on Tillicum, which are a little bit different than modules on Clone. So if you're switching from Hayek clone to Tillicum and you plan to use modules, you want to give that a look and make sure that you know all the differences so that you can jump right in. One of the main differences is that we have a hierarchy, which is to make all of the compilers that are compiled with specific software easier to use, but sometimes a little bit harder to find if you're not familiar with that. And finally, we support Python environments, of course, so we have a Conda module in particular, which is our recommended method to use Conda on Tillicum, and it's something that's different also from Hayek clone that we hope is going to make everything easier and just more efficient with your storage. Right. That being said, modules, installing software natively, all of this can be done in a container as well. But what is the difference between a container and just installing something straight up or another method? So a container is a lightweight, isolated software environment that encapsulates an application along with all of its dependencies and its runtime settings. So you can think of this as the host computer. It's running Rocky Linux, like I just said, but you have software that depends on something very different. Well, let's just go with something that's not that different, but still different enough. Ubuntu, for example. And so that's the requirement. This software developer only wanted their software to be installed in Ubuntu. How do you do that when you can't control what the baseline image is? Well, you can have a baseline Ubuntu container, install it inside the container, and now you have this plugged in resource that is a Ubuntu operating system, everything that you wanted to use to run your software, and then it's using the host's hardware, but in an isolated way. So what this really means in practice, what are the differences? What are the things that I have to do? Well, you have to install all of the software that you want. It must be installed within that container. So you have to use a command called Apptainer build, and we have a few methods that we're going to demonstrate to allow you to do that. But you'd have to do that anyway, right? You'd have to install your software anyway. You'd have to install your modules or your packages into your specialized Conda environment anyway. So that's not that different. You have to do some installation. And then you must also activate that container before you're able to use it. So you can shell into the container and be in that isolated environment and running things interactively. Or you can make a whole one-liner command just to send what you want to do to be run through the container. So that's not too different either, right? Like maybe you don't have all of the software that you need on Hayek or Tillicum natively, and you have to many times activate a module or activate your Conda environment. So it's not that different. These are just different words to do the same thing. So why use a container? Well, it's consistent, it's reproducible, it's a fully packaged software environment. You can take it and use it on Tillicum, you can use it on Clone, you can take it over to AWS or Google Cloud Platform and plug it in there and start it with your instance. It makes your research reproducible, and any other changes that happen to the host or that happen to the Python environment that you decided to use for another project are not going to affect the workflow that you've built for this container. It only counts as a single file and a single storage item in Tillicum, and on Hayek, we do have limits on those types of things. So it can make a lot of this easier and more performant when we have a mounted parallel file system. So are they hard to build though? Like how much am I jumping into the deep end with this? Well, many of these containers are already ready-made and they exist. So a lot of when containers hit the scene, a lot of developers got behind that because they said, oh, I can not have to deal with so much tech support if I am able to fill this gap of folks having so many dependency issues just to use my software. So they actually maintain themselves certified images of their software pipeline or programs, even down to like niche software just for this one bioinformatics pipeline. Sometimes you can go to their site and find that, or just Google that software container and see if you can find it from someone else who has already contributed that, adapt it for yourself. And then definition files, which is like kind of like a recipe file for your container. These are repeatable, reusable building. You can build upon them. So hopefully if you ever have to rebuild, you don't have to start from scratch over again. Just use a recipe file. And you can share that with others as well, if they have an Apptainer runtime on their system. So why might you not use containers though? Like, sounds great, but is it gonna work for me? I would say there are two cases that are really just one case that you might consider using a different method. So you might want to, it does require, whenever you have a change in your requirements or your dependencies, that you need to rebuild your container. So if you sense that you're very much in a discovery phase or code development phase of your research, and you're gonna be making a lot of changes all the time, you're discovering new packages all the time that you need to do something, you may decide that going with the conda module and your specialized conda environment is going to be faster for you to just kind of plug in new packages as they come up and as you find that you need them, than waiting to like fully rebuild your environment. It doesn't take that much longer, but it is a step that you'll have to do. So if you're doing more interactive development, you might decide to stick with the method that we present in the onboarding tutorial for Tillicum. And so there's a little, like I said, the second point here is just emphasizing that it's a little bit less flexible for quick experimentation. There's a little bit of wait before you can test it out. So it's a little bit of a longer trial and error development. Sometimes all the containers we're using today are very quick. All right, so I wanted to go over just what we're after for today. So by completing this tutorial, we want you to learn how to work with Apptainer containers on Tillicum. This will be pulling the container, learning how to inspect it, and running containers. I'll teach you how to make a sandbox environment, which allows you to interactively build and install software, and how to build from that recipe file, that definition file that I was talking about. We'll also talk about and have an example of accessing shared datasets on Tillicum. And then how the example that I've laid out actually allows you to run a GPU accelerated deep learning inference inside a container. But it's a very rudimentary example, so just saying it had to be fast for this tutorial. But hopefully you can get inspiration from that, use it to set up your own definition file and your own test methods to adapt to your research project. And then just to wrap everything up and to add in another skill that I know that you need, we will show you how to submit and monitor batch jobs with Tillicum using Slurm, which is our job scheduler. I'm not going to go too deeply into Slurm today. We don't have a lot of time, but it is an essential skill. So I encourage you to look at the Tillicum Slurm training that we had a few weeks ago. That's already online in the repository to review those methods. And we have other trainings about Slurm on Hiat Clone that if you're not able to use Tillicum after today, you can also practice over there. So need to knows about today's training. I have made a training group, a training account for all of you to use for the next 3 days. And you can use that to go back to this training on your own independently. You can test out, it's enough time that, you know, if you're free tomorrow or if you're free all weekend and you want to test things out on Tillicum, that you can use this account to do your own explorations as well. But on Monday morning, I'm pulling the plug on that. So you have this limited time of access for this tutorial for your own exploration to learn about Tillicum. Additionally, I do want to say, if there are any folks in the audience that already have Tillicum accounts, for your exploration, you should use this account because it's free. And I'll show you how to switch between accounts as we go along. The Slurm account name is Train Container 2025. So I'll show you when that comes up. And like I said, it's ending on Monday morning. So what we're going to do for the rest of the day is that I have built a GitHub repository with, it's meant to be gone through in sequential order. It goes through first just some fundamental tasks that you'll need to do, fundamental commands of using Apptainer. And then it has a task which builds in, that's the GPU accelerated deep learning stuff that builds in a lot of these tasks together. So we'll kind of go through a lot of different phases or reasons why you might use Apptainer, things that you might encounter in the future, and then we'll have like a worked example of what you might do. And so I will say, all of this, your accounts are ready, all of this is available to you to do on your own. And I am going to walk through it in real time so that you can go through, and as questions come up, you can ask them. As I see something to mention, you'll have that kind of improvised explanation of what I'm seeing. So you can stick around, or at this moment, if you have something else to do and you want to handle this on your own independently, you're not going to hurt my feelings at all.
So it looks like the Apptainer command line is just the word Apptainer.
Yep.
And that's something that I can install in my Linux environment.
I suppose, yeah. But if you're the owner of your Linux environment, I don't know why you'd need to have Apptainer.
I'm thinking.
Well, I guess to make a container, yeah, locally and then ship it somewhere else, yeah, you could do that.
Okay, but is this what people tend to do, or is the model, I log into Tillicum and I start using the Tillicum bash shell, which has Apptainer already installed? Is that the idea?
That's what I do whenever someone says, hey, I'm having trouble installing this software on Hayak or Tillicum, can you help me out? And I see that, oh, either there is a container existing for them that we just need to customize, or they're having a lot of problems that a container would make easy. I open up a shell on Tillicum or Hayak and I just start making a container right there. Yeah. So that's how I would. Any other questions? One more sip. Okay. Switch gears here. In the PDF, there are a few more slides in here that just have links to some helpful pages that if you want to learn more about research computing in general, you should check. Okay. So like I said before, I have made this repository available for you on GitHub. Hide these controls again. And I've written the link here on the board. I think Kai-Chen has posted it in the Zoom chat. And so from there, I'm going to go ahead and start by getting us logged in to Tillicum. And get started. I only have one screen, so it might take me a few seconds to get things set up. Okay, so I always start by opening up a terminal since I'm a Mac user. And the login for Tillicum is similar to the login for Hayak Clone. It is SSH. And then your UWNet ID, so don't put mine, it won't work for you. At tillicum.hayak.uw.edu. Execute that, and then you put your same UW password for all of your UW things. It won't show my password, and it won't even show me that I'm typing as a security measure. So if you are wondering why you don't see your cursor moving, it is so you can share your screen during a training and you're not giving up any special secrets. I have my notifications off on my laptop. All right. So once you see the message of the day and our artwork here, saying Tillicum AI, then that means that you have reached the correct host and you are in Tillicum login node. I am Finch KN at Tillicum login. You might be at another Tillicum login node, but this is where you always start. I'm also in my home directory, which has this address for me. Yours will have a different address using your UWNet ID. And you should know that this space only has 10 gigabytes of storage, so we're not going to be using this for our workshop, and you shouldn't really be using it for anything except essential files. Instead, I'm going to make a working directory in our scrubbed directory, which, like I said, is the temporary storage. It automatically deletes itself if it hasn't been modified in 60 days. So I'm going to change directory into GPFS, scrubbed, And then I already have a directory here for my name. But if you do not, you should make a directory using this command. mkdir, that's make directory. And then the money sign plus user is your variable, which always is replaced by your net ID or your username for Tillicum. So if you've done that, you should go ahead and cd into that directory. Mine is empty. I don't have anything in here. Yours probably is too, unless you have been using Tillicum before. And then we're going to clone the GitHub repository so that we have all of our stuff that we need in here. And if you have the email, you can just copy the link to the GitHub repository, or if it's open on your screen. But I'm going to go ahead and type it out just to save us some time, or to spend some time. Git clone www. Oh no, it's https://github.com/tillicum-containers.git. And now if I list my directory, now I have something in there. So my GitHub repository has been pulled from the internet and saved as a directory within my working directory. So I'm actually gonna cd Tillicum containers and go into there. And that's where I can list my resources that I have for this training. Oh, right, so I was here, okay. So like I said before, there are already pre-built containers out there. So I'm gonna go to dockerhub.com. This is a main source of containers that I tend to use. I tend to always come to Docker first and try and look for containers. There are many, many containers, even some that are, specialized. What's something? SAM tools for the biology or bioinformatics folks. They even have the state public health bioinformatics community is a great contributor of public resources that are very well maintained. So this one is a SAM tools version only from 4 months ago, rather than some of these other ones are even newer. So definitely pay attention to the source and try to get a reputable one. But if you have some very, very obscure software, it might be something you have to create yourself. Or it might be elsewhere and not in Docker Hub, but in someone's GitHub repository. They have a Docker file, which you can change into a Apptainer file by switching out some commands. Another great one for Tillicum especially is NVIDIA NGC. I don't remember what that stands for, but it's a catalog of containers and other things that they have built for folks to use with their GPUs. I find that these are the best containers on Tillicum. We will be using one later, the PyTorch container.
I have a good dumb question.
Oh, no, there's no dumb questions, Rob.
I demand the right to have a dumb question. So when we were at Docker Hub, earlier we saw we were going to be using Apptainer, which is a different flavor of container than Docker.
Yeah.
So does the Docker Hub simply host Apptainer containers?
No, Docker Hub hosts Docker containers, but Apptainer can convert them into it can convert a Docker container into an Apptainer container.
Okay, and there's no peril.
Not that I've seen.
Okay. Yeah. Thank you.
I will say one downside or some need that I feel has not been filled by Apptainer is that they don't have an equivalent repository for Apptainer images. They do have some, but they are not as well used as Docker. And I think because Apptainer can just convert Docker containers, that's what they're satisfied with. So hosting your Apptainer container publicly might be, or sharing it with someone might be something that you are not able to do fully publicly unless you have a storage that you can expose publicly, which we do have options for, like Copa. Our S3 storage is an option for that. Depending on the size, you might need to consider some other options.
And here at NVIDIA, is it strictly Docker also?
These are, so they have their own kind of container repository, but you can pull them via Docker. And yes, they are Docker containers, but they have their own repository called NVIDIA IO.
Okay, so if I go to NVIDIA and I pull a container from them, which you say is the gold standard in using Tillicum, then I still need to do a convert to Apptainer.
No, I'll show you. So that's our next step.
Okay, sorry.
Great segue. All right, so let's pull our first container. Let me just put this away. Okay, so we're back on Tillicum and we're back in our shell. So Apptainer is installed natively on Tillicum. And for small operations like this, like I was saying, you can be using the login node. I'll show you how to start a Slurm job later. But the command to pull these from Apptainer, or pull a container that is hosted on Docker Hub down to Tillicum using Apptainer is Apptainer pull docker : // and then you put the tag of the container that you want. And I'm just going to put Python. And it's going to pull the latest version of the Python container from Docker Hub. So before I execute that, I'll just show you that on Docker Hub, they have Python, official Docker images. And if you go to tags, they show you that they have many, many different versions of Python available, but here's the latest version, which will be pulled automatically if you just put in Python. We'll find out more about it in a second. So go back to our execute this. It should only take a few seconds. I might already have cached this before, so it might take a little bit more time for you. I was testing this last night, but it should take 30 seconds or so. So now you have this, which is called a singularity image file format. So why is it called singularity image format? Is because Apptainer used to be called Singularity, and they had a rebranding when they went fully open source. That's cool. That is a container image, and all Apptainer images have this ending. So it's pulled Python latest version from Docker, it converted it into an Apptainer container. So let's go into the container. You can see, or if you haven't used Tillicum before and you haven't installed Python in any other way, if you just type in Python, which would usually open the Python shell, it is not here. We do not have a version of Python natively installed on Tillicum for you to use. Thus, you need some way to use it. And like I said, there are other methods, but this is the container method. We're going to use the Python that is in the container that we just built. To access it, we're going to shell into the Apptainer container and then open the Python shell. As mentioned, this is a way to activate your container and your Python environment. So Apptainer shell Python _latest.sif. All right, and now you see that my command prompt has changed to Apptainer. This helps you know that you're inside of a container. If I type in Python, now I see that my Python shell looks like just like it would, and that this container in particular holds Python 3.14.0. All right, so if you want to exit that, you would do Control D to exit the Python shell, and then if you wanted to get out of the container completely, you would type exit. And now if you try Python again, it's still not here. You have to use Python from within the container. Another way that you could do the same thing, but let's say you don't want to go in and work interactively, instead you want to execute a command via the container, you could do Apptainer exec for execute, Python latest, and then Python -- version, which will just spit out the Python version without us having to go into the container, start the shell, and then ask for the version or see the version. So then how do I pass a file that is outside of the container through the container. This is one thing that I want to point out is a difference with Hayat clone. With Hayat clone, you have to bind the file system to the container to be able to access files on the outside. But with Tillicum, you don't. We just set it up in a slightly different way. But I'll show you how to bind or not bind, just so you can have practice with that. So in our materials, I have this Python file called py.py. If we cat this file to the screen, we just see that it imports math, and it says a little statement printing inside of the container, and then it says math equals, and then it has the Python package maths version of py. So if I want to execute that file or that run that script with my container, I'll do Apptainer execute Python latest, and then Python, and then py.py. And ta-da, it has taken your script and run it through Python, executed it within the container, and it gives you your py. If you are on clone instead, you would need to do Apptainer exec --bind /gscratch. /gscratch, and then the rest of the command. If you do find that Tillicum is not able to find your files for whatever reason, you should do bind gpfs Python latest container, and then Python py.py. It doesn't change anything, but it has maybe redundant access or even better access to the files that are outside of the container.
Sorry, is the program py.py saying no? Executing inside the container was printed by who?
Printed by the script.
Ah, okay.
So sorry, my command prompt is not giving me a full return on that. Instead, I could. Oh. Here's a better way to see the script.
Okay, got it. Thank you.
Yeah, so I just put a print statement. I just said executing inside the container. Just to drive the point home. All right, any questions on that so far?
Yeah, there's the bind, just bind to whatever directory that's in the container.
You only have to give it the top usually you only have to give it the top directory of the file system. And so none of these files are inside of the container. And for the way we have that set up on clone, that means that it can't see any files that are outside of the container unless you bind the file system. We set it up slightly different to make it easier on Tillicum, so you don't have to do that. So it can see what's on the outside.
So it just needs the top level of the file system
Mhm.
to traverse down the tree.
Yep, that's why I did bind. It would be bind gscratch, just your scratch, or bind gpfs. Choose that. Yep. Any other questions? I just want to show one more command with Apptainer, which is kind of like one of the fundamental things. There's also a command called Apptainer run. And this is very specific. We'll run into the run commands, but there's a section of your recipe file for your Apptainer containers called a run script. And that's where you can put whatever you want. And for all of the Python containers, in the run script, if you put Apptainer run and then this container, it will just start the Python shell. But it doesn't have to do that. You can customize that yourself. So if I do Apptainer run Python latest with nothing else, not asking for Python, it will just start up the Python shell, and then you have Python available to you this way to work interactively. And then when I exit, when I stop the Python shell, I'm not still within the container. So it's like a different way of working interactively with the container without being inside of it. We'll make a custom run script in a little bit. All right, so we're going to build a custom container, but this time we're going to build with Ubuntu. So we're going to start with an Ubuntu bare file system. And I'm going to show you how you might want to work interactively or like in real time testing your software installations, and then you can like. It's called making a sandbox, that's your interactive version of the container, and then you can like output it to be the container standalone itself. So we're gonna pull another container from Docker, Apptainer, pull Docker : / no space, Ubuntu, and that's it. Like I said, I already did this last night, so it's probably still in my cache. But you would have seen some more text from Apptainer here. So if I ls-ltr to see the most recent thing, now I have my Ubuntu latest container. So just like we had our Python latest container, now we have Ubuntu latest. It's just the most recent version that was added. It's an official Docker version of Ubuntu. Another command that we can use is inspect. So Apptainer inspect Ubuntu latest. And this will give you a little bit more information about what is inside of the container. So it's saying that it's from Docker, it's Ubuntu, and it gives you a version of the container. I don't think it gives you a version of the Ubuntu version specifically. You have to go inside for that. But there's a little bit of information. This can also be customized. All right, so there is something that we know is natively installed in Tillicum, and it's Git, right? So we used Git earlier to clone our repository. So we know that Git has a version installed natively on Tillicum. It's 2.47.3. But if we wanted to do Apptainer exec for execute Ubuntu git -- version, we see that there is no git executable within the container because we haven't installed it, and like I said, it comes as a fully bare container. So how do we fix that? There are a few ways. We need to rebuild the container so it has git within it. You have to install it as you're rebuilding. So one method to do this is the sandbox method. This is a way to interactively install things into your container. I don't personally like this method. I like to have the recipe file so I have a paper trail of what I did to prepare my environment. But I do want to say that this is not. So to make a sandbox,
I'm sorry, I have to stop for yet another question. The Ubuntu image and CIF file that we're looking, Ubuntu latest.cif, was pulled from Docker Hub?
Yes.
Therefore, it's a Docker container.
Yes.
And you were saying that in order to run on Tillicum, we need to be in Apptainer format. You're operating on this Docker container file using Apptainer. Was there something that happened in here, or did I miss something?
I just pulled it from Docker, and so it converted it into Apptainer.
So the Apptainer pull command automatically converted the Docker image into an Apptainer image.
Yes.
Thank you.
But when you inspected it, it still has this paper trail of saying that it was from Docker. All right. So now we're gonna make a sandbox from this Ubuntu latest container. Apptainer build -- sandbox. And then Ubuntu. Oh, actually just do the Ubuntu thing, but then remove the .sif and then give it again. Basically, we're telling it, build me a sandbox. This is what I want you to call the sandbox, Ubuntu latest, and build it from Ubuntu latest.sif. Okay. Did it happen like immediately like it did for me, or it went pretty fast for everyone? Okay. So what that does is it converts the container into a directory where you have all of the contents of the container inside the directory. So if I ls my Ubuntu latest directory instead of the container, then it shows me what is very familiar if you work with a lot of operating systems, a baseline file tree for operating system. These are the standard directories that are part of an Ubuntu operating system that is completely bare of all of it.
Excuse me, can you give a command on the Ubuntu sandbox?
Yep.
Ubuntu.
It's right here.
Got it.
So if you wanted to go in and inspect any of these. If you wanted to go in and inspect any of the files and directories. If you wanted to inspect any of the files that are in here, you could. We're not going to. We're actually going to shell into a writable version of this sandbox so that we can make a change to it. So if you went into this directory and you changed anything, it wouldn't work. But it's kind of unpacked the container into a file system that we can write into if we run this next command, which is Apptainer shell.
Here it is.
Apptainer shell dash writable dash fake root Ubuntu _ latest. So what we're doing is we're asking Apptainer to give us an interactive shell into the container that's writable, so I can make changes in there to things that are inside of my sandbox. I want to be a fake root user, just saying that I should be allowed to do things that I asked to, and then give it the destination that I want to go into. And you're going to get these warnings that are just saying that it's going to open into the fake root or the root of your Ubuntu operating system, but we know that that's not the root of our total Tillicum, right? But we're in there, so you can ignore those warnings. They're not telling you anything bad. And we're going to install Git into the container now. So whenever you're working in Ubuntu, the very first thing you want to do is apt-y for yes update. This gives you an updated list of packages that are available to Ubuntu from the internet. Then you do apt install. I wanted to do apt-y. This just says it asks us yes or no, do you want to install? And if you give it the flag -y, you're just already telling it that yes, you do. And it's going to be apt-y install git. And there we go. Now we should have Git installed in our container. In our sandbox, I mean, it's not quite a container at this point. And you see it's a different version of Git that we have natively on Tillicum. So that's how we know that it's different, right? All right, so let's say that we had a whole bunch of other stuff to do. We have a bunch of other packages and things that we need to install in our Ubuntu system. You could do that at this point. But I am going to exit the container, and I'm going to show you how to take that container that's now customized with Git and turn it back into a standalone Apptainer image that now can be used in standard way.
I have a question.
Yep.
Earlier we did a command that took the CIF file and converted it into an entire Unix file system,
Yep.
Ubuntu file system. Still a little unclear. Are we right now? We have the Apptainer prompt, so we're inside the container.
Mm-hmm. Inside this container sandbox, technically.
Inside this container sandbox, which is not the CIF file.
No.
Container. It's the image of that we created.
The unpacked version.
The unpacked Ubuntu file system.
Yeah.
So by using the Apptainer command, we jumped into that file system as root, where we're doing all these apps.
Yes, as if we were in the container itself, but you can't usually install things in the container just with Apptainer shell. You can only install it if it's first been converted to the container sandbox where it's unpacked, and then you can install things interactively with Apptainer shell.
Okay, so the model I should have is I want to start modifying my container environment. Therefore, I create the sandbox, and I use the Apptainer, I forget what the command was, but exec or something.
Yeah.
But I go into that sandbox environment, and that's where I actually do the configuration stuff.
Yes. Yep.
Okay, and this is like fundamental every single time basic workflow. This is what I do.
No, No, this is only one method of customizing your Apptainer container.
Is it the best method?
No. The best method is the next method.
Okay.
This is the method that you can use. So let's say that you've installed more things, or you haven't, we haven't, but we're going to take our sandbox now and we're going to make our permanent Ubuntu plus Git container version of this unpacked container sandbox. So we do Apptainer build again. And this time we're gonna give it our new CIF container name that we want. And to just to differentiate it, I'm gonna call it Ubuntu _ Git .sif, because this will tell me that unlike Ubuntu latest, this one is the Ubuntu version with Git inside of it. And then you pass it the Ubuntu latest directory. So now it's like repackaging all of that plus Git, which we installed into it, into a SIF file. And now if I do Apptainer exec Ubuntu latest, oh no, not latest, Ubuntu Git .sif, and then do git -- version. I see that my Git version is there, and if I just do Git version on Tillicum natively, oh, spell it right, then you have different versions. So another benefit potentially of containers for you is that your Tillicum baseline file system is not compatible with what you're trying to do, and there are things that we are maintaining for all of our users that are not compatible with your own custom environment. You can have a completely different version, even old version of your software isolated into a container and available for you to use. I found a mitochondrial phylogenetics paper from someone like a few years back when I was a postdoc, and all of their R packages were super out of date. But I wanted to use their pipeline because I like coding in R. And I was able to make a custom R container by installing all of those old versions of those packages that weren't even maintained anymore. And that helped me to use that method that these folks went through a lot of trouble to publish. I would say if you're in that case of wanting to publish a whole R protocol and you're not going to make your own package and maintain it yourself, container. All right, so now I'm going to show you the best way to customize a container, which is to have your recipe file. We all love to have our, we love to have notes. Notes that we're taking now are notes to our future selves about the stuff that we did that helps us to stay on track with our research project. Especially if you have years and years long research projects and you need to go back and say, what did I do that day? I always prefer to have a definition file or some kind of notes so that I know and have a picture of exactly what I did to build that specialized computing environment. So I have made for you a definition file to look at. Hold on. It's called container build.dev. So cat container build.dev, and now we can look at it. So this is my command prompt here, so it kind of got messed up. But we're doing something that's very similar. This is the structure of a recipe file for Apptainer. You always have Bootstrap. So where is it getting that baseline environment that you're going to start with? In this case, we're getting a baseline environment from Docker, and it is going to convert it into an Apptainer container. And then we're telling it the tag that we want. So not just Docker, but specifically we want Ubuntu. It's going to pull the Ubuntu latest container like we just did, but this time it's going to do more stuff in the same command. In the post section of the Apptainer recipe file is where you put all of your instructions to install your customized software. We're going to update our list of packages that are available, and then we're going to install curl and install Git. I'm hearing noises like maybe people are talking on Zoom. Anyway, if you're on Zoom and you have a question, you can just interrupt. I cannot look at the chat right now and Kai Chen. And then another thing that I'm including here is the run script. So remember I said if you use Apptainer run, it will execute whatever you want it to. This is where you build what you want it to execute when you use the command Apptainer run. So with this new custom container that I'm building, that we're gonna build together, it's gonna have curl inside of it, it's gonna have git inside of it, and then when I run Apptainer run with this custom container, it's gonna execute curl version and git version automatically. Any questions about this structure? There are other sections of Apptainer definition files that allow you to do more things, like set up your environment variables. You can write your name into it and say this container was developed by whoever. You can sign your name. You can apply other security measures if you wish. There's a lot to talk about with this, and I'm linking to the Apptainer docs where I think that would be the best for you to review if you're gonna have if you're gonna get more and more advanced in Apptainer customization. So we're gonna go ahead and build our custom container from that container build.def file. We're gonna use Apptainer build, and we're gonna give it the new name of our SIF file. So I'm gonna call it custom-container to differentiate it and call it .sif. And then pass it that container build.def definition file. So it's saying Apptainer build me a new container called custom container.sif from my recipe file container build.def. So as you saw before, it pulled the container, it's updating packages, it's installing Git. Now this part you didn't see before, it's installing curl. And now it's creating the SIF file, it's very fast for me. And now I have my custom container.sif ready to go. So like I said, I want to execute the run command to make sure that it's gonna do what I asked it to do, which is give me the curl and git versions that I installed. Apptainer run custom. And this is not the best in my opinion, but the curl version command gives you a lot more information. So it just gave me everything there. And also the git version. I don't know, do we have curl on Tillicum? We do. We also have, let's see. Looks the same. Oh, except it's a different release date. We have the old version of curl. And the one that we installed in the Ubuntu container obviously has some security patches specifically for Ubuntu operating system.
Sorry, could you remind me the build command? I got kicked off and I've been logging back in. So it's Apptainer build and then the target SIF that you want to create and the definition file.
Yep.
Thank you.
All right. So there's another way to build containers, and it's from a container version that you already have in your directory. So let's say that you're running R, you have your R container, and there's a ton of packages in there, and this container rebuild takes you 15 minutes or something like that. And you only need to install one more package, and it's not behaving nicely when you just do install .packages and then that package. You want to try and install that into the container directly so it has everything that it needs. It's able to pull all the dependencies that the container cannot get to. You can build from the existing version of R container that you already have. You can build on top of it. And this is how you do it. Except for us in the room, we're going to be doing that, except we're going to install. I forgot, so let's just look at the recipe file, but we're going to install a package into our Python container that we pulled earlier. So let's look at the from local build.def. So I called the other one container build. This one I'm saying from local build, just to differentiate it. All right. So the bootstrap is changed here. It used to say Docker, because we were pulling a container baseline from Docker. Instead, this time, we're just gonna use the local image that's already in our directory as the baseline, and we're gonna use the Python latest container. And Python, this container in particular is also an Ubuntu file system baseline. And so we're using apt get again, apt update, and then we're gonna install with pip, the no cache directory. We're just gonna install our basic Python packages that we all know and love for data analysis, NumPy, pandas, and matplotlib. Here's what I was saying, you can set your environment variables. This export variable just means that it puts this into my path, which you don't really need to do here. It's really just an example that if you wanted to do this later for yourself, you could. And then on our run script, we're just saying, start the Python shell and then tell me the versions of Python in these print scripts or print statements. So when I use Apptainer run, now my new customized Python container, it will automatically import those packages and just show me the versions, which you might never have to do, but it's just to say, just to prove that they're in there. That's we're doing all this. All right, so Apptainer, we're gonna build this now. So we're gonna use Apptainer build again. We're gonna call this one custom-python.sif. It looks weird. Sorry, let me clear my screen. You guys can keep going. Okay. Apptainer build custom-python.sif. So that's what I want my new container to be called. From the definition file called from local dot. Oh. Did I spell it wrong? Got it. Yep, from local-build.def. So it's verifying that Python latest image is there. It extracts that, so it's basically making a sandbox, but all in the cache directory, right? We're not able to see that happening. And then it's installing those new packages with pip install. And now it's making my new SIF file. So the main thing here is that we've built custom containers in 3 ways. We use the sandbox method to install Git into Ubuntu. We used a definition file to also install Git, but also curl into Ubuntu from an existing Docker container. And then we made our custom Python container, which uses our Python latest container, which we already pulled from the internet, and just installs more packages into it. And now we can do our Apptainer run custom Python. And this should run my run scripts, which just starts Python, imports NumPy, pandas, and matplotlib, and then I go to these print statements just to give me the versions of those.
Sorry, there's a lot going on here. Can you remind me where the run script exists? Like,
Yeah.
how would I go and find out that it's running numpy or -b or on numpy?
Yeah, so there's a section in your definition file starting with the %run script, and this is where you can just put kind of whatever you want.
Okay, so that's starting a Python shell. It's importing those libraries.
And then it's just these
And then
print
it's-
statements,
Okay,
and then the version command. You can have it do the whole, whatever you want it to do this way too.
right.
You could have a whole application coded in your run script. And it could take like your arguments inside too with your command.
Yeah, so what if it needed to know an integer? What would that look like?
That I cannot answer.
Like,
I don't know.
let's say we do what you just suggested and we write this entire Python program that calculates whether n is even or odd. How would you pass it a value of n in this?
I've never tried that, but I would think that you could just use like money one. for your argument as you would with a bash script. You can copy data also into containers. It doesn't have to be outside. So you could have more scripts that are inside of the container. For example, I have a container that is just a Python thing and I'm only running these certain Python scripts. I put the Python scripts in there. So now my Apptainer command is Apptainer execute my, let's just call it's called locator, this Python program. Locator container and then Python and then the locator script, which is inside of there. And then I can give it the rest of the arguments because I've coded, actually someone else they've coded the Python script to take the arguments. So you just do dash dash drop out. It's like a neural network. So you can actually pass not just the Python script, but the arguments that the Python script are taking. That's not with the run command, but you could do it the same way, I'm sure.
Yeah, that's
Hopefully
great.
there's an AI that knows how to do it.
I'm sure there is.
Someone knows how to do
I
it.
have no doubt.
Sounds like it's just like our cursor.
Yeah, exactly.
Yeah, the Apptainer run documentation says all following arguments are passed to the run script.
There you go.
So if you just append your arguments, they'll pass on.
So when I was making the locator container, someone else made the, the scripts and stuff. I could have just taken that locator.py script and put it into the run script. And then I wouldn't have to call Python locator. I could just start doing with the args and say Apptainer run container with all the args. They could have got past it that way. There's a lot of options. Any other questions? Oh, I was gonna actually do one other thing here. So we have a custom Python container now that has NumPy, pandas, and matplotlib. So we can do things with that now. This little script called plot example.py. It just makes a little, it's making data to make a sine wave and then plot it on matplotlib and then output your plot. So just to show you how you would pass a Python script into my Python container is this. Apptainer exec Python, oh sorry, it's custom Python first. And then Python, because we're gonna give it a Python script, plot example.py. And it gives us a little bit of output showing us what our data looks like that was generated on the spot. And it outputs our example plot.png. Example plot.png right here. Of course, you can't look at this plot on Tillicum, but I would like to show you a little side quest by going to the internet and telling you how you can get something off of Tillicum that is on there. So Tillicum is set up as a Globus endpoint. This is a graphical user interface that you can download things that are on Tillicum to your computer. What's even better than that is you can set up your computer as a local endpoint, making the transfers even better. So you can just give Globus a path on your computer, and you can give Globus a path on Tillicum, and you can say, move that over here, and it does that, and it's fault tolerant. So if you have very big file transfers, this is the best way to do that. So it will check and make sure that all of these transfers have happened properly, and it does this unsupervised. So you don't have to like stare at it and make sure that your internet doesn't die or something like that. So let's go to Globus. If this is the first time you're doing this, there might be more authentication steps necessary, but I've logged in a few million times. It's not asking me to authenticate right now, but I just went to globus.org and I found the login button at the top right. I have some of my collections that I use often come up in recent, but you can also bookmark them. We have Hayek Clone is an endpoint, Copa is an endpoint. I have an endpoint set up for my local computer, and then we have a connector for UW OneDrive as well. But for now, I'll just go into Hayek Tillicum, where I can navigate by clicking through the file tree and go to the file that I want, or I can put a path in here. So I can go to gpfs/scrubbed/finch kn/tillicum -containers. And if I spelled everything correctly, which I did this time, then I'm actually gonna sort it opposite way. So I just put last modified, so it's up here at the top. I can see my example plot is there. And I have a little download button over here on the right side. You can expand this so it tells you what this is. If I select this and put download, it didn't ask me to authenticate again. I mean, I've already downloaded it before. But now it's in my downloads directory on Finder. Great. Ta-da! So that's the way you can get things back. Like I said, a better method is to set up your local computer as a endpoint with the Globus Connect Personal. I have linked in the, I think it's in the task documentation page, I've linked to the other documentation that tells you how to set that up. But I can have Kristen's MacBook Pro over here in a 2-pane view. And I can do the same thing. I can find my, downloads directory. And I can transfer it again. Or maybe I'll just transfer something else. I'll transfer one of these pages over to my downloads directory on my computer. It tells me that that started. It also sends me an email when it's done. Great. There are other things you can do. You can time your transfers and everything. All right, so that's our side quest. Anyway, just saying, use Globus, please. We paid for that, for all of you to use it. It's a beautiful thing. Okay. There we go. Now we're getting into the task, the final thing. So what is this going to bring together and what is our goal? Our goal is for you to learn how to customize a GPU-enabled PyTorch container, run image classification on a shared dataset, so that's one of those data commons datasets, monitor GPU activity. There are many ways to do that. I'm only showing one way because I thought that would be of interest to you. I don't know if it will be very useful for you, but just to be a sanity check that these are GPUs, you are running them on GPUs, and you can monitor the activity if you so wish with this one way. And then we're going to submit that workflow with a batch script using Slurm on Tillicum. All right. So fortunately, our preparation step is already done. We're already in our working directory. We have cloned our materials. And now we're going to start our first Slurm job on Tillicum. Well, maybe not the first for you, but we're going to start the first of this example. I'm going to clear my screen. Slurm is a job scheduler, and it means that with all the requests that come in from all of you users on Tillicum, it decides how to most efficiently allocate those resources, those GPUs to you, playing like a 3-dimensional Tetris and saying, oh, this person needs this many for this long, so I'm not going to schedule anything here, and then I'm going to put it here because just these fine resources are available for this person, and so on and so forth. All right, so to request an interactive session, we're going to be doing stuff that's a little bit more costly in resources, and today it's not going to cost you anything, but it would be a chargeable job. But we're going to have an interactive job so that we can work with a chunkier PyTorch container, which causes more processes to be running.
Sorry to interrupt. My colleague John Mitchell has a question in the chat.
Oh, John Mitchell, can you read for him?
Oh, I'm actually not logged into the call.
Thanks. Chat anyway. Okay, are y'all planning to have the depths of common builds like the one we just ran with git curl? Well, so the definition files that we just used are in the GitHub repository. So those are there. I am trying to get it to catch on that we have a repository for common Apptainer images also. And I'll show that to you, but it hasn't quite stuck just yet. Because no one probably knows about it, but we go to our UWRC, like organizational GitHub. I have made an Apptainer images repository, and I tell you how to contribute to this repository. And there are a few in here, but these are just a few that I made. Like if I had one that I thought that someone else would use and it was resulting from a support ticket that I was working, then I published it here. So one is like a star, it's like a bioinformatics pipeline for RNA, I believe. And then this one, FSL, is a MRI image processing software. They took me a long time to help the user build them, so I thought let's make sure that everyone knows about them. So the definition files are here. So I'm trying very hard, not very hard, I guess. I guess I'm not trying hard enough. I would love it if people would start to contribute their definition files here if you think that other people are going to be using them. You can make a pull request, and I can even like give you feedback on that if you want, or try and make it more generalizable for everyone. I would love that. Oh, he said awesome. Thanks, John. All right, let's get into the task then. Unless are there any more questions in there?
No, just that you could do an entire class on how to,
Use GitHub.
yeah, use GitHub to preserve some effort in this Apptainer space. Just a future thought, you know, just in case you're wondering
Yeah.
what to do tomorrow.
Yeah. Okay. I do know that if you don't use GitHub as our whole website is on GitHub, so I have to use this like very frequently. And I do know that if you're not using it as much, then making pull requests and stuff like that is not second nature. But I'm happy to share the knowledge with anyone who wants to do that. Okay, so we're gonna start a Slurm job so we can make a beefier container that has PyTorch in it. So the command to start a job very simply is salloc. And then Tillicum uses what's called a quality of service, or I just think of them as Q, like QUEUE. This is like a bucket of jobs that you're submitting to. QoS equals, we're gonna go with interactive. We have different QoSs that are meant for different purposes. They have different time limits. They have different maximum number of GPUs that you can request. But for this, we'll just use interactive, and we'll request GPUs equals 1. We'll each just request 1 GPU. Yeah. Anyway, I'll come back to that before it goes away. But we're just gonna say time, and we're gonna do 1 hour. And this is how you do 1 hour. If you do 1:00, it's just 1 minute, which is not very useful. Okay, and so if you have another Tillicum account existing and you don't want to be charged for the jobs that you're doing for the rest of the weekend, this is required.
You can choose these to account.
What was that?
Choose these to account.
Did I spell it correctly? The train container 2025. Yep, that's it. All right, so a little bit about and we're all waiting. I also don't know how busy, okay, mine came up. I don't know how busy the queue is right now, but everyone has equal priority on Tillicum. So what it tells you is also, it tells you how much you can expect to pay for this job. But it's an estimate based on the amount of time, like I said earlier, that you requested. So this is thinking it'll cost me 90 cents if I let this job go for the entire hour, which I probably won't. But it will stop charging me like very precisely on the second that it gets the termination signal. But it gives you a little bit of a warning there. This is also where if you are hitting a budget limit that your PI has set up for you, it will also tell you. And then it tells me that my job started on G024, and I don't know why my command says bash 5.1, but I think other people's command probably say their username at. Is that correct? Okay, maybe since I'm a OG user, I think that mine just hasn't been updated. But anyway, it's more helpful for you the way that it is. One way that we know that it is a GPU is we can run NVIDIA SMI. Table doesn't make nicely for a small window. But it shows you the CUDA version, the driver version. These are uniform across all of the Tillicum GPUs. And it tells you that you're on like only one of them, and you can only see the one GPU that you have access to or that you have started up with, or the number of GPUs. You can't see all the other GPUs that are on that server. One single server has 8 GPU cards within it. If we had another, you could set up another window. Also, in this, I'll just show you how to do it. So if I start another window, actually I'm not, because it's gonna take too long, but you could log in to Tillicum and SSH2 G024 and just have a watch command on NVIDIA SMI, and as you're sending those jobs to be executed, it would show you the activity fluctuating on NVIDIA SMI. So it's a really great way, it's not tracking it, but it's a really great way for you to know that your GPU, your code is being utilized with the GPU. Okay. All right, so we're going to use a data set called ImageNet. This is a open source data set. It just has a whole bunch of images of random stuff. And we have a little script that uses a model called ResNet50. It's a PyTorch inherent model for testing. And it's just going to classify that image as what it is. So it's going to give a description to the image. So it's going to be like dog or cat, or sometimes they have more random things like trench or something. So anyway, let's go ahead and we're going to just do this with 5 images at first, and it is very fast. I tried to like increase the number of images to make it take longer, and I could not make it take longer than 20 seconds at all. It is so fast. So we're just going to do 5 images because then we can look at them easily and see if our classifications are correct. We're going to make a new directory called sample images. And there it is, it's made correctly. And now I'm going to use a command. It's going to go, you don't always have to do this with our common data sets. There are ways to tell PyTorch this is where the ImageNet data is. But just for this, we're just going to go into that directory, pull out 5, and copy them over here. We're going to use the command find /ppfs. That's where all of the files are, but it's under datasets, under ImageNet, and then it's in data. Oh, no, it's not. It's in ILSVRC/data/CLS. If you have the GitHub open, you should just copy it. And then /val for the validated images. -name. And we're going to look for only files that end with JPEG. So star for wildcard.jpg. Pipe command, we're going to pipe that into a shuffle command. -n for 5 images. And then another pipe. You should just copy it. xargs -i open curly, close curly, CP, open curly, close curly, to here, which is the dot. Oh. Ah, man, I didn't CD into the sample images first, so now I have a mess. So I want to move all of my .jpegs into my sample images directory. If you don't do that, our script will not work. Okay. So now they've moved out of my other directory, but they're in sample images. So if you actually went into sample images like the instructions say, you want to go back to the, now they're here. You want to go back to our Tillicum containers directory and be here. Okay, now it takes about, oh, there's one more. We're going to do a wget command. Since most of you might be able to, is anyone typing this or are you able to copy? Is it okay if I copy instead of type it? If I go to the GitHub repository. And I go to task. There's a wget command, which allows us to give the labels for all of those images. Which is called ImageNet classes. So let's just look at the first few lines of that. And we have trench, goldfish, great white, shark, etc. Is everyone at this point?
Why does it say tench?
Tench. I thought I was reading that as trench this whole time. I don't know what a tench is.
Carry on, not important.
We're gonna look it up. Okay. All right. So normally, if we were pulling a PyTorch container from the NVIDIA NGC, that's what we're gonna use, the NVIDIA version of PyTorch, the latest version available, or actually, they don't have a latest, you actually have to say the version. It would take 7 minutes. So instead, I copied it into a place on Tillicum that you can all go and grab a copy of it to use for yourself. But at a later date, if you want to practice pulling the PyTorch container yourself, it would be Apptainer pull docker :/ and then a longer anyway, that you'd have to go here and go to PyTorch. Into tags. And then you would find this address and copy it. And you would paste it like this. So that's what pulling, it's a Docker container, but it's in NVIDIA's repository. And that's how you would pull this one. But we don't have to do that. We can just copy it from GPFS, containers, NVIDIA, and it's the only one in there right now, to here with a dot. That's done. All right, so one of the fundamental things that we're wanting you to learn how to do is it's not just it's just a PyTorch container. There's nothing else in it. So if I have actually there's a ton of things in a PyTorch container. It has a lot of the things that you already need. It has Torch Vision is already installed, CUDA is already set up. Everything is in there that you essentially need. But if there is a package that you hear about that doesn't come pre-installed with the PyTorch container, this is how you would install it yourself. We're going to build a new version of the container from this local image with the definition file that I've put in here called PyTorch_TIMM.m. All right, so just like previously, we're starting with a local image and we're giving this image that we just copied into our directory. We're going to install with no cache TIMM. We're going to export an environment variable called Python unbuffered. This means that it won't hold on to the warnings that it's giving you. It's just going to print them directly to the screen and be a little bit faster. It's optional. You can add a maintainer. I'm just going to have it be the words your name. You can change it later for yourself. And it gives a little bit of a description about that. So if you want to ever add any labels to your container, that's how you would do it. And then our run script, right? What's going to run when we use Apptainer run this container? It's going to echo this container includes tip to test Python, to test use Python-C and then import tip, which is what we'll do to test that it works. So just a tiny bit about Tim. I wanted to load an image classification like model, or not the model, but a toolkit that's widely used by deep learning users. And it's maintained also by the PyTorch community, but it wasn't already installed in the PyTorch container. But that it's really great for this type of work that we're doing here. So just as a demonstration, we chose Tim.
Sorry, how did ResNet fit into this?
So ResNet is, it's already inside, that's coming in the next step, but it's the image that, or the model that we're gonna, the pre-trained model that we're gonna use to classify those ImageNet images into their labels.
Okay, so Tim's not doing the classifying.
No,
We'll find out what Tim is doing.
yeah. It's a deep learning library. Is doing something, okay. It is the fast example for something that wouldn't take too long to install that I found. That might be relevant for this. Okay, so Apptainer, just like last time, build. This time we're gonna call it PyTorch dash Tim. Actually, on the instructions, I think it'd be shorter to just call it PyTorch dash Tim, but we'll do what the instructions say. Which is PyTorch underscore Tim with the version of the PyTorch container, which is good practice. Except I don't like that extra period in there. Alright, so we're building a new container, a customized container, which doesn't just have PyTorch, but also has PyTorch with Tim from our definition file. This one could take a few minutes. So I can answer any questions that we have now. No questions?
Is there any way to build the image locally? Can I just install Apptainer?
You could, yes. So you could install Apptainer. I think it's only for Linux though. It might work well on your Mac, but not elsewhere.
Also,
I've never installed it myself and I've never tried to manage the software, so.
seems like you can do Docker too. Just-
Yeah. So you can also, that's what Rob's training is going to be about. And the nice thing about using Docker is you have that repository too. But the chip, anyway, we have to talk about something later. But yeah, go on.
You have to, since the PyTorch image uses or connects to the GPU, do you have to launch the GPU before you build the image, or do you do that?
No, I think that this probably would have worked on the login node, but since it was a little bit heftier, like it's taking a little bit longer, I wanted us to start a job first. There is a very important flag that we have not encountered yet that is required for running GPU containers on NVIDIA hardware, which is --NV. If you just run your container, it will not turn on the GPUs. You have to pass --NV, and that tells Apptainer that this is a GPU container. You need to have access to the host kernel, which includes the NVIDIA driver and CUDA and all that.
I have a question about this. What's executing now is a recipe build.
Mhm.
And
From the
it's,
local PyTorch image.
right, so that's what was my question. Does the recipe text, the recipe, the dot, is it def?
Yeah.
File text include explicitly the PyTorch CIF?
Yes, so at the top it says bootstrap local image, so it's saying start from a local image, and then I'm given the from commit part of it. It is the exact file name of that CIF file.
Okay.
Yeah. We could have easily done bootstrap docker and then from, and then given that whole address in the NVIDIA catalog. And it would have, instead of building from a local image, it just would have pulled that from Docker and then started building on top of it. I decided to do it from an image this time, just to drive the point home about building from local, but it would have been probably save a little bit of time. Maybe not. It would have taken
That's
probably the
okay.
exact same amount of time.
My only goal is to understand how the gears are connected.
Yes. No worries. You're probably just saying what everyone is thinking. Explain this more.
Got another question.
Yep.
Do all Docker containers now convert? Because I think it used to not always convert to singularity.
Yes, so that was not a Docker problem or an Apptainer problem. It was, this happened to me, I got a new Mac chip. and it was incompatible with Hayak. Hayak is like an AMD 6.4 chip, and my Mac is like a newer chip. So I need to make a platform agnostic Docker container because it's still, I think that is explicitly against like the whole Docker concept, and I was really like frustrated with that when I was a postdoc. I'm like, why no work? New computer. And anyway, I think that they have hopefully fixed that, but I'm gonna talk to Rob about that to make sure that the Docker containers that we're showing how to not have that issue. There are in Docker Hub. No. In NVIDIA, you see how some of these say 2 architectures, 1 architecture, 2 architectures? So because Hayak has that potential issue, I would always stick with the ones that have 2 architectures. So they've basically made 2 versions of this container, and when you pull it, it will find out which one you need. But with Docker Compose, you can make a container locally that is cross compatible.
Okay.
So anyway, Rob, we'll have to like make sure that is clear with the Docker training coming up. All right, my container build, everyone else get to this point where you have a successful success? Okay. I will move forward. Just to show that we can test this as we always do. So Apptainer XEC. So actually, yeah, well, let's run the Apptainer run command first. So Apptainer run PyTorch Tim. This one? So what it says is this container includes Tim. To test, run this. So that's what I'm going to do next, is I will use Apptainer exec PyTorch Tim. And then I'll just copy this from up here and paste it, and it should print my Tim version. Okay. So it took a little bit longer because it is, loading that container and then it's executing it. We don't see very, very big performance issues with containers, but it's needing to activate the container. The container has a lot into it, and it's so fun. That could have been more responsive in my opinion. Okay. So for our image classification, we also have a script that does the image classification. Basically, it is going to take as input a directory of images, which we've already prepared. It's going to import the Python modules being Tim and Torch with and the image utilities. It's going to load the ResNet 50 pre-trained image classification model. It's going to load the standard ImageNet labels, which is where it's getting the answers that it wants to put together. So basically, the ResNet model, it's just going to spit out a number, which is the index of the label that it's training. And I've asked it to do a second step, which is to compare the index to the actual word description so that we can see how well the image classification went. And then it's going to report a little bit about how much GPU memory is used per image classification. And that's it. So we can just, if you just want to look at it, it's called infer _ tim.py. It's not that long, but this workshop isn't really about this script. It's about your script that you want to run in this way. And you can borrow whatever you want to from here to do that development, but I'm sure you already have your scripts that you just want to show through Tillicum, right? I just needed an example that does something that we can assess the results on our own. So we're going to go ahead and run this image classification with our container. Apptainer execute. This time, remember, we need to pass the NB flag. PyTorch Tim. And then our container is next. We're gonna start Python. We're gonna pass our infer script. And then we're gonna give our input sample images directory. And then I'm just gonna give it a file name where I want it to save the answers that it comes up with, and I'm gonna call it output_labels. So pretty fast, it loaded the container, it started the Python shell, it passed the script through it, and then it took in our images, classified each of them, and I only asked it to print to the screen the memory used. I didn't ask to print to the screen the answer. So if I cat our output labels, I see that we have ear, water buffalo, angora, liner, and marmot. So if I go back to Globus, I have one side of Globus is Tillicum and one side of Globus is my personal computer. Into the downloads, you probably got different answers, by the way. We all had a separate list of images. If I go into sample images, and if I just select all of these and I transfer them into my downloads, we had one that was, let's see, one was ear. This one ending with 8648. Oh, it's ear of corn. Very good. So there you go. Let's see. Marmot, water buffalo. Oh, a liner. Here's liner. Cool. And I guess that's a bunny.
It's an angora rabbit.
Oh, okay. Cool. I ran this a lot during the testing and I only got it incorrect, or I only got an image incorrect one time. It was of someone wearing a light blue sweater, and the sweater had like a piece of fabric that came over here with 3 buttons, and it classified that as a diaper. Which old school like cloth diaper, maybe like cartoony diaper with buttons, could be. Anyway. The last step is that we can do the same thing, but we can send that with our Slurm script. So we have a script that ends with .slurm. It is classic Slurm script. It has all of our SBatch directives, our job name, account, same thing. Later, you'll want to change that because this will not be available on Monday or after Monday. We're going to use a normal QoS this time, just one GPU for 10 minutes because it's so fast. And we're going to ask it to output the output and error streams to a file. We're setting up a few variables with bash this time so that our command can be simplified by passing those variables. And then we don't have to change our command. We can just change the variables at the top in the future. So to send that for scheduling, just do xbatch. And it's so fast, I'm glad that I caught it. But see, it's already over in 11 seconds. But if you had a longer running job and you just apply a watch command to your SQ and your username, then you can see your job here that it'll rerun that SQ command every 2 seconds by default. And so you can watch your jobs kind of going in and executing in real time and completing. And if you're expecting your job to take a lot longer than 10 seconds, you can see if it failed, right? And you can say, oh, something wrong. And then you go immediately to check it out. This is the job that I'm running right now, right? Because we also have an interactive job running. So this is the job that's running. And the other job that disappeared now is the one that I sent with Slurm. You do Control C to exit the watch command. And if we ls-ltr, we have our infer with our job ID, so yours will be a different file. And I asked it again just to print how long this took, and also the GPU memory used per each image. And it's loading a little bit of information about the GPU that I have on there. There is a special challenge on the GitHub repo, which is to transform this into a Slurm array job, where instead of running all of these as a for loop in Slurm, instead it will pass each image, or actually a set of input directories. So you make a new set of directories, right? And then you pass each directory into a different job stream and you execute those all in parallel. It's a fun challenge you can do from the repository on your own, but we do have the script answer is up here called array inference. So after you try that on your own, you can see if you got it right. And we have a Slurm training that goes more into depth about array jobs, but it's a great way where if you're doing the same thing to many sample sets, or you're doing a parameter sweep where you want to walk through different dropout types or anything like that, array jobs is where you are making the most of your time. Instead of running everything serially and waiting for all those jobs to complete in a sequence, you can reduce and just have one job time running all of your jobs. All right. That's all I have for you guys. We made it through. It is 3:02. So if you have somewhere to be, then you're free to go. Question?
Current allocated job.
Right, so if you want to stop your job, which you should, just exit. Now your job is revoked, you're back on the login node. Oh, and if you do Hayek budget, oh no, Hayek usage, sorry. This shows me my usage on all of my accounts. So let's scroll up a little bit. I have a lot of accounts. But these ones are the most important, so we have a container training, that's the account that you are all a part of. And I show my 5 jobs there, and this is just showing my usage by default. And the total usage, I set like a soft budget of $1,000 just to see how fast you guys could go. It's not gonna stop any of your jobs, but go nuts. And then this is our UWIT group. But if I did Hayek usage dash u all or dash a train container 2025, hopefully this will work. Yes. Now I can see all of you that were able to, that are following along and running jobs in real time. So great work. We didn't do anything very heavy, of course, but this is how your groups can monitor your own usage on Tillicum, and how PIs, especially if you have a big group, can monitor usage. Setting up a budget or the usage limit is something that's an admin action only. So you have to reach out to us and we'll set that up for you. Okay, any other questions?